Good day, Evan Sneeman for Local, Making a Difference. Today we're looking at our third video in the trigonometry section, 3D trig. Now, again, the problem with the 3D trig is simply that it's very difficult to visualize, that the complexity, there's no new work to it. Okay, so if I gave you a sum like this, and I asked you to find, so let's say I gave you this basic sum here, and I said, cool, this here was alpha, this was, okay, this length here was B, this was C, and I gave you some angle here, this was beta, and I gave you, I don't know, let's make this part here D, okay? And I asked you something along the lines of, please find the size of this angle. Now, what you can see in this diagram actually are two triangles left and right, but there's also a third triangle, the entire shape. Now, most teachers will tell you, look at the two triangles left and right and tell me how many facts you know about them. Well, currently in this left-hand triangle, I know D and beta, so I know 2 facts. In this right-hand triangle, I know alpha, B, and C, so I know 3 facts. Okay? So they will tell you that the fact that I know 3 facts in this triangle tells you start here. Okay, so we want to start on this right-hand triangle and we want to manipulate ourselves into finding, and again, almost every single teacher will tell you that this line here in between the things, the line that connects the two triangles, has to be your target. Okay, so we are going to start in the triangle where we know 3 facts. Okay, and we're going to target the line that connects the one triangle to the next. Now, this is how we dealt with 2D trig. Okay? For 3D trig, it is exactly the same. Okay? Nothing is going to change other than it is harder to visualize the 3 dimensions in an exam. Okay? Now, unfortunately, you're not encouraged to take any tools or any toys into the exam venue. So how you visualize this 3D trig can be a little bit complicated at times. The best thing I can suggest to you is maybe prior to the exams, or some stage now when you're doing the chapter, maybe go outside and see if you can use some ropes or some sticks or something and make a couple of 3D shapes and try and get your head around how some of these things interact with one another. Okay? But the concept is the exact same. We're going to find a triangle where we can see 3 things, and we're going to use that triangle to target the other things. The only other thing I want to talk to you about is, again, when I say it's exactly the same, let's talk about these 2 situations. Okay. Again, just some basics. Okay. And this one here, let's do another one here. Let's suggest that I know this angle, this side, and this side, and I would like to work in this triangle. Okay, as opposed to I know this angle, this side, and this side. Now the key question is, do I have an opposite pair? Okay, so do I have an angle and the side that is opposite it? So do I have an opposite pair? And here I've got an angle and its opposite pair. So if I do, okay, then it is the sine rule. If I don't, it is the cos rule. Okay? Now please remember those 2 rules are given to you on your formula sheet. You do not need to remember them off by heart. Some of you might choose to do so because it's faster. But again, this is the theory behind what we're doing. As I said to you, it's exactly the same as 2D trig in grade 11. The only difference is now we'll be adding a layer of complexity, because instead of having a two-dimensional flat on a plane, we're now pulling it out, wires holding up a mast, height looking up at a shape in the distance, etc., etc., etc. It is not quite as straightforward as previous. Okay, so all I'm going to look at now is 3 exam questions, and let's have a look. Now, again, not totally easy to see, and thank goodness again in this case that they've shaded the bottom triangle, okay? But again, it might be possible that your printout doesn't, the shading's not come through clearly like that, for example. So what becomes really, really important in this topic is the reading of the text, okay? So B, E, and D are points in the same horizontal plane. They are on the ground, okay? So for me, I would read that B, E, and D are on the ground, okay? So in other words, it's very difficult to color it in here, but B, E, and D, I would suggest we see as being on the ground, okay? On the same horizontal plane on the ground, okay? A, B, and C, D are vertical poles. Now they've drawn them slightly bolder here. Again, if they're not drawn slightly bolder, take out a pen and mark them slightly differently so you can see that they are vertical. Okay, that means not only is AB perpendicular to BE, but believe it or not, AB would also be perpendicular to BD. So it's also going to be perpendicular over there in the same way that this is going to also be perpendicular over there. A pole that is perpendicular to the ground is perpendicular in all directions to the ground. Okay? Steel cables AE and CE anchor the poles. Yep, I can see those two poles and they come down to the same anchor point. Another steel cable connects A and C, the top of A to the top of C. Okay, they give you some distances, some lengths. Okay? Please be very careful with how you mark these lengths because it can be difficult to see which piece you mean. Okay? CE is 8.6, BE is 10, and AEB is 40, AEC is 70, and CED is 27. Now, again, if you were to look at this shape and to think about it, what you might decide to see is that this back shape here is a vertical, funny shape here. This triangle ABE is a right angle triangle starting out, let's say, towards you, and there is a right angle triangle CDE over here, similarly, that is slanting out towards you. What might not be immediately obvious is how the 70 plays in, okay? And that is that you've got a triangle that is sitting here, kind of slanting away from you, okay? Nothing about it is right angled, nothing about it is vertical, nothing about it is horizontal. It is just a triangle sliced away from you. Okay, now, okay, let's have a look here at these various shapes. Okay, if we were to take this right triangle here, we said was ABE, we currently do know 3 facts in it. Okay, so the good news is we do know 3 facts. Okay. If we were to look at this triangle over here, which we said was CDE, okay, there we also know 3 facts. Okay, the right angle, 27 degrees, and 8.6 meters of the length of the cable. Okay, the triangle ACE, this middle triangle, currently we only know 2 facts. Okay, and the bottom triangle, okay, the BDE, the horizontal plane that's currently labelled with currently shaded in slightly dark brown, slightly grey, we only currently know 1 fact, and that is that BE is 10. Now, you can draw these triangles on the side to help you understand things, and I'm going to choose to do that for question 7.1. For 7.1, I'm going to redraw triangle CDE. And if I was to redraw triangle CDE, I'm going to get this sort of shape. Okay, there is C, there is D, there is E, badly drawn, so let me redo that. There is E. We are told that this angle is 27. We are told that this length is 8.6, and they're asking us to find CD, which I'm going to call Y for want of a better label. So we know that therefore sine of 27 equals Y over 8.6. Therefore, Y equals 8.6 times sine of 27 equals, okay, so 8.6 times sine of 27. I'm getting an answer of 3.904, so let's leave it at 3.9. Okay, so CD is 3.9. Now, not only have I marked it on my in my sum, but I've also got to put it on the diagram to help me see things better. Okay, the length of cable AE. Okay, well again, I'm going to do the same thing. I'm going to redraw the diagram. There is AB, there is BE, there is thing. We know that's right angled. We know that that is 10. Okay, and we know that this height here, the angle of elevation here was 40 degrees, and they want us to find AE, so we're going to call that, I don't know, the cable, so let's call it C for want of a better letter. So what are we getting here? 10 over C equals cos of 40, therefore 10 over cos of 40 equals C, so 10 divide cos 40 equals 13.05. Okay, so this length here was 13.05. Okay, please notice that when we found 3.9, that helped us with triangle, with the green triangle, the triangle that we're saying yes here on the right, but did nothing for the triangle that was slanting away from us. Okay, when we found the length of 13.05 for AE, not only did we find that length of 13.05 for AE, but we now find an extra value inside this triangle. So this is no longer 2 facts, we now know 3 facts. Okay, and that allows us to now work in that triangle. So to find the length of triangle AC, to find the length of cable AC, we now have a diagram that looks something along the lines of this. Okay, that is 70. Again, it's too thick to write, so let's go with 13.05 and 8.6. Okay, again, we don't have an opposite pairing, so we're going to use the cos rule. So therefore, AC squared equals 13.05 squared plus 8.6 squared minus 2 times 13.05 times 8.6 times cos of 70. So let's put this one in. Answer squared plus 8.6 squared minus 2 times answer times 8.6 times cos of 70 equals 167.5, 575. We're going to square root that. We get an answer of therefore AC equals 12.945, which we should say is equal to 12.95. Okay, cool, sorted. Move on to the next question. Okay, effectively the same, 2 towers on running up a plane, okay, except for the fact that these 2 towers are not connected in the same way with cables in the same as in the previous question. Okay, so again, reading it, P and Q and A and B are 2 vertical towers. Absolutely, I can see that. Okay, so again, I'm just going to quickly come in here and choose to mark it as such, so I can just see that a little bit better. So these 2 are 2 vertical towers. Wonderful. Okay. I can see that these things are on the same horizontal plane, so I'm going to choose to just mark them with the same color. Okay, so P, Q, and R, from point R, the same plane as Q and B, so these are all on the same horizontal plane. So for me, as I said to you previously, I would read that as being on the ground. Okay, hence I'm choosing to use the color green to mark them. The angles of elevation are theta and 2 theta. Okay, so this question immediately is different from the previous one where they gave us actual angles and now they're giving us variables. Okay, and especially when they're giving us the variable 2 theta, certain little alarms are going off in my head because I know that 2 theta has a role to play. Okay, AQR is 90 plus theta, and again, even they had trouble marking it. Okay, it's not easy to see. QAR, yes, okay, cool. So just finding it. QAR is theta up at the top here, and QR is x. Okay, cool. So let's have a look here. In this funny triangle over here that's standing up here, okay, I do know three things because I know there's a vertical. In this right-hand triangle, I currently know two things. Okay, and in the slanting triangle over here, I know theta, x, and the 90 plus theta. So I know three things in this triangle. So I could choose to work on it right now. Okay, find QP. They're nice and friendly to start with. Find QP. Well, QP over x is going to equal tan of theta. So QP over x equals tan of theta. So QP equals x tan theta. 2 marks. Woohoo! Great. Okay, AR. As we said before, you always want to target the connecting line, and in this particular case, they're asking us to do that first. So again, nice of them. Okay, so we want to find AR. So what we're going to do is look at the facts we have here. Do we have an opposite pairing? Well, actually, it's not so easy to see, but yes, we do have an opposite pairing. So if we were to redraw this diagram, okay, what we would see is we'd see a diagram that looks something along these lines. There is a theta, there is a 90 plus theta, and there's an x. And so yes, in fact, we do have the opposite pairing because there it is. Okay, we have an opposite pair over here. Okay, again, they're asking us to find this one over here. So let's go back and let's go for it. So we know that we need to use the sine rule. So therefore, AR, wrong color, yeah, right color, AR over sine of 90 plus theta equals x over sine of theta. Sine of 90 plus theta is equal to cos of theta. So AR equals x cos theta over sine theta, which we could see as being x over tan theta. But I think that most examiners would accept that second line of cos theta over sine theta, x cos theta over sine theta. So again, not as easy, but achieved. Okay, show that AB is this. Now again, it's a run-on question. Okay, so AB, where is AB? AB is the length of this tower. Okay, so again, we've got a right angle triangle, which right angle triangle tells us we need to use definitions. So if you're going to use a definition, and we're looking for this one over that one, for that angle, that would be sine of, sine. So for 6.2, sine of 2 theta equals AB over x cos theta sine theta. Okay. Okay. Cool. I'm happy with that for the moment. Okay, so we're going to times across. So you're going to get sine 2 theta times x cos theta over sine theta equals AB. Okay, so we now do have AB on itself, but what we do have on the right hand side is firstly a sine of 2 theta. Okay, we have a sine of 2 theta, which is screaming at me that I'm probably going to be a problem. Okay, I've got this over here, which is a problem, and I've got my denominator of sine theta. And again, please remember, we can target the question. Okay, so if we look at this question, there are no sine thetas involved in this answer. There's only cos of theta, so it's telling us effectively what we need to do. Okay, so what we're going to do is we're going to change that sine of 2 theta out. So we're going to get 2 sine theta cos theta times x cos theta all over sine theta. Those sine thetas cancel, and we've got 2x cos squared theta as required. And we've finished with question 6.2. 2x cos squared theta equals AB. So in a previous video, I did warn you that they do embed double angles and compound angles in other topics, and here we've got one where they've embedded it inside 3D trig. You can see that this is one of the later questions, okay? And you can see from the mark allocation that this is worth more than the other questions. Okay, AB over QP if theta equals 12. Okay, so let's just see if we've got enough information already, which I'm pretty sure we do, but let's go have a look. Okay, so AB, okay, is 2x cos squared theta. QP we found earlier was x tan theta, okay, and that equals AB, sorry, let's just fix that, AB over PQ. Okay, the good news is that the x's will cancel. The other good news is that we know that sine, that tan is sine over cos. So we've now got 2 cos squared theta, or we don't even need to do that, we can just use the over tan theta equals AB over PQ. But they do tell us that theta is 12. So all we're going to do is just going to simply take out that theta, okay, and put a 12 in, because it tells us theta equals 12. So for me, fraction 2 times cos 12 times cos 12 divided by tan 12 equals, and I get an answer of 9.002. Okay, equals 9.002. So we're going to say it's almost equal to 9. Okay. I do have one last slide, so let's have a quick look. A lot shorter. Okay. No hints here. No scaffolding. Straightforward. What looks like 2, maybe 3 triangles, and 7 marks all in one go. So half a symbol all in one question. Now, for some people, these questions are frightening. For other questions, these questions are exciting because they're stimulating. How can I rise to the challenge? Okay, so again, let's see if some of the hints we've had can't help. Okay, so we've got a triangle in the background. Okay, that is right angled. We know the H and we know the beta. So in that background triangle, we know 3 facts. We can start there. In this front slanting triangle, BAD, okay, we currently know the 2 beta, okay, and that looks like pretty much all we know right now, so we're going to have to do some work. Okay, yes, we know a third fact, BA equals BD, okay, so because we know that BA equals BD, okay, we know a second fact. We don't know how long they are, but we do know a second fact that these 2 things are equal. So currently in this big triangle, starting down here, we know 2 facts. Okay, so let's go. We've said this before, we need to target the in-between line. So here we go. I know it's a bit cheesy, but I like doing this sometimes. Drawing for me what looks like a little target. Okay, that's not meant to be a fingerprint, that's meant to be a target. Okay, so I'm going to target that line. So let's go to the back triangle, okay, ABC. And in that back triangle, we know that it's right angled. We know this is H, we know this is beta, and we know that this is the one we're looking for. Okay, so AB, H over AB equals sine of beta. Therefore, H over sine of beta equals AB. But they tell us that this is also equal to BD. Okay? So again, let's now look at the big slanting triangle we've got coming down here. We know that this one here is 2 beta. We know that this one is H over sine beta. You know, this is H over sine beta. We do know 3 facts in this triangle now. Okay, and unfortunately we do not know an opposite pairing, and since we do not know an opposite pairing, we're going to use the cos rule. So again, it's going to be a little bit tedious, but bear with us. We're going to simply set it up. AD squared equals H over sine B squared plus H over sine B squared minus 2 times H over sine B squared times cos of 2 beta. Okay, find the distance between these 2 things in terms of H. Okay, so we've now got h squared over sine squared beta, two of them, minus 2h squared over sine squared 2 beta times cos of 2 beta. Okay, so what's this going to become? Okay, okay, so again, the issue here is they're saying in terms of h. So in other words, the betas are probably going to fall away. Okay, the only variable in the answer is going to be an h. So again, we know that the things are going to fall away. Okay, so let's see what's going to happen. So we've got 2h squared over sine squared beta times 1 minus cos of 2 beta. Okay, so again, let's look at our options. Cos of 2 beta can be written in 3 different forms. The context only has signs, so we're going to change it into a version that has got only signs. So 2h squared over sine squared beta times 1 minus 2 sine squared beta, okay, which is equal to 2h squared over sine squared beta times 1 minus 1 is gone, minus minus is a plus, 2 sine squared beta. Again, those will cancel, and we've now got 4h squared. Okay, but be careful, because this is what is AD squared. Okay, and they've asked us to find AD. So therefore, AD equals simply 2h. Okay, that was a nice question. It was challenging, was different, was stimulating. We knew that the answer needed to work out to something that involved just h's, and so when the betas cancelled out close towards the end, the faith that we had in doing our steps cautiously and carefully was borne out, and at that stage, a lot of, not doubt, but a lot of caution that I was having about the sum fell away because the betas fell away, and I was left with just h's, which satisfied the question. Write down your answer in terms of h. Okay, thank you so much for this. Have a great day, and good luck for your maths going forward. All the best.